So topic 4, which is related to electrochemistry. The questions are related to electrolysis. The first part, dilute sulfuric acid is electrolyzed using an apparatus as shown. We have inert electrode. Usually inert electrodes are made up of carbon or graphite, or we can also say platinum. But lab, the cheaper one is a carbon, so we use carbon. State what is meant by the term electrolysis. So it's a breakdown of ionic or a molten compound. Means a breakdown of ionic compound in molten or aqueous state by passing the electricity. Explain why inert electrodes are used. Why we use inert electrode. So what might be a reason? Because they may react with sulfuric acid. They may not react with the product form, you can also say, or does not react with the electrolyte, sulfuric acid. Because, for example, if you use any metal, say zinc you are using, so that may react with the sulfuric acid. So it does not react with electrolyte. Name the product formed at each electrode. So when we are doing the electrolysis of a sulfuric acid, we have hydrogen ion, we have sulfate ion, we have hydrogen ion, and we have hydroxide ion. So the electrodes, we have anode and cathode. Now what will happen? Like this is an anode example, the positive terminal, and this one is a cathode. So hydrogen ions are common here. So hydrogen will move towards cathode. So at cathode or negative electrode, we get hydrogen. Then we have hydroxide ion and sulfate ion. Remember, sulfate, nitrate, or carbonates never move during electrolysis. Even they are more or less, even it was a concentrated sulfuric acid, they will not move. So what will move? The hydroxide will move there. And whenever the hydroxide ions move there, the equation for hydroxide ions, that 4 hydroxide ions, when they move, they will give oxygen and they will give 2 water molecules and loses 4 electrons. O2 plus 2H2O give plus 4E. So the product, that is the oxygen. So whenever hydroxide will move there, right, oxygen. Ionic equation for negative electrode, as a hydrogen ion is moving there, it will take 2 electron and it will form a hydrogen gas. So bubbles will be seen. This question is related to the moles. Dilute hydrochloric acid react with sodium carbonate. The chemical equation for the reaction is shown. So we need an equation as well. So the first part, 25 cm³ portion of a sodium carbonate was placed in a conical flask and few drops of the suitable indicator was added and it was titrated with a hydrochloric acid of 0.18 mole per dm³. That's the concentration. 20 cm³ of a hydrochloric acid was required to reach the end point. What is the meaning of end point? Means it's a point where the indicator shows a color change. That we called as an end point. Calculate the number of moles of HCl used. So how to work out the moles of HCl used? We have the concentration and we have the volume, but the volume is in cm³. We have to convert into dm³. So the moles equal concentration into volume. The concentration is 0.18 and the volume is 20 divided by 1000 to convert into decimeter cube. So we got 0.0036 or 3.6 exponent minus 3. Whenever you solve the first, you always use a formula. The second part, we'll use a ratio because for sodium carbonate. So we'll take a ratio between a hydrochloric acid and sodium carbonate. What is the ratio between them? According to equation, if we have 2 moles of hydrochloric acid, we'll have 1 mole of a sodium carbonate. So ratio is 2:1. In the question, we were having a moles of hydrochloric acid, which is 0.0036. So how many moles of sodium carbonate? X. So we cross multiply. So when we cross multiply, it will be 0.0036 divided by 2. So we get 1.8 exponent minus 3 or 0.0018 mole. The last part, we need the concentration. So how to work out the concentration? The concentration is moles divided by volume. So how many moles of sodium carbonate? It is 0.0018. And the volume of a sodium so the volume of a sodium carbonate solution was 25 cm cube. So must be in dm cube. So we'll divide by 1000. So 0.025. So 0.0018 divided by 0.025. That will give us 0.072 moles per decimeter cube. That is the concentration of the solution which is used in this experiment. The next, in another experiment, the volume of a carbon dioxide produced was 48 cm cube. How many moles of carbon dioxide are there? It's a gas and the volume is given in cm cube. So you can use a formula that moles equal volume of the gas in decimeter cube divided by 24. Or volume of gas in cm cube divided by 24,000. So both are right. So this will be, because it is in cm cube, we convert into dm cube, divide by 1000, so 0.048. So 0.048 divided by 24, we get 0.002 moles or 2 exponent minus 3 moles. In part C, a sample of a concentrated hydrobromic acid was electrolyzed using a platinum electrode. The concentration of the hydrobromic acid is 8.89 mole per dm cube. What is the concentration in gram per dm cube? So if you want to convert the concentration from mole per dm cube to gram per dm cube, we have to multiply by the molar mass. What is the molar mass of a hydrobromic acid? HBr. What is the mass of hydrogen? 1. What is the mass of bromine? When you will use the periodic table, 80. So it means the total mass will be 81. So what we do, this 8.89 multiplied by 81, and you will get the concentration in grams per decimeter cube. So whenever you want to convert the concentration from moles to gram, you will always multiply by the molar mass of 1 mole. Explain why concentrated hydrobromic acid conduct electricity. Aqueous concentrated. So whenever it's an aqueous solution, so whenever something dissolves, the ions are free to move. That's right. Good. So ions are free to move. So when we pass the current, the ions move towards their respective electrodes. So concentrated HBr aqueous dissociate or break down into ions, and ions can move through the electrolyte or within the electrolyte. It's of 2 marks. So how the marks are distributed? 1 mark, ions are free to move. The second mark, ions will move through the electrolyte when we pass the current. Magnesium is not suitable material from which to make an electrode. Why? Because it is reactive. That's good. Predict the product of anode when hydrobromic concentrated is electrolyzed. So we have H plus, we have Br minus, we have H plus, and we have OH minus. So towards the anode, the positive terminal, the negative ion will move, which, because it's a concentrated, the concentrated means like contain more bromine, less hydroxide. So as a result, the bromide ion will move, and as when bromide ion will move, it will form bromine. So bromine will be the product. In exam, you're not supposed to write the formula. You have to name a product here. If they ask like give a name of a product, then you have to list the product.